So this evening, I'm going to start out by talking about two airplanes that had the opportunity to do design work on, build and flight test them. The primary objective of these vehicles were proof of concept vehicles to show that the configurations, as weird as they were, could actually be flown by a pilot and landed. That, in its basic nature, was interesting enough. The first one I'm going to talk about is called the paraglider, and this is the paraglider being built in shop. Now at NASA at the time, there were two groups of people. One who felt that doing this type of flight test was not necessary. You could do everything you needed to do in the wind tunnels. But as you know, as experienced pilots, that what they come up with in the wind tunnels may or may not represent what the real world is once you get in the vehicle and you start flying it. And so a proof of concept was good. The paraglider's initial requirements were to provide a methodology for landing the Gemini capsule horizontally on the ground rather than splashing it down in the ocean. Well, that never came to fruition, and I'll get into the details of why that didn't in just a little bit. But the initial concept was, could a man actually fly this thing? There is the vehicle that we're on the taxiway starting our testing flight. Rogers Dry Lake, which is the lake bed behind us, it was wintertime when this happened in December. And I'm going to back up just a little bit. When this group of people that didn't think that we should be doing this kind of flight testing come to the end of the year, were a lot of old timers. And in the government, if you're not familiar with them, you could carry a certain amount of leave over every year. And there's a certain amount of leave, if you don't use it, you lose it. It's called use or lose leave. And so when these people were all on the last month of December using up all their use or lose leave, our center director, in all his brilliance, got another guy who was a designer and builder of small aircraft together and says, what would it take to build this? And from the time our center director told us, go ahead and build it, 10 days later, we had this vehicle sitting in the hangar. It said, once the lake bed dried out, then we got out onto the lake bed. And this is the configuration here I call BB, and that's before Bruce. And I'll tell you more about Bruce later on. NASA's Flight Operation Division had this kind of a vehicle, which was an international carry-all. And we used it initially to tow the paraglider. And we literally wore every one of them out that they had. Because going down the taxiway and on the lake bed, it was wide open throttle from the beginning to the end of each tow. And with that, we ended up with those vehicles, and the vehicles were white and we had to have a yellow top on them. NASA, that was our color code, what we had to have in order to drive on the taxiways and the lake bed. That was an Air Force requirement. This is another shot of our pilot, Milt Thompson, there, and my boss and myself out on the lake bed when we could finally get out onto the lake bed. That was, and of course, being aircraft type at the time, we thought, when we went to build a sail, of course, what did we use? We had to use aircraft linen, right? So we bought a bunch of aircraft linen, we doped it up, but we had no method of stitching it or thing, so we sent one of our engineers with this big bolt of linen down to a sailmaker down in Long Beach. And we showed him the plan we wanted to lay it out with, and he looked at it and he says, well, you guys could go ahead and do that. He says, but you're going to have problems with this and that and the other thing. We said, well, but this is our plan and this is what we want you to do. Stitch it up, and he did. That's what's there. And all the problems he said we were going to have, we had. I mean, there's a gentleman that had been designing and working with fabric flapping in the breeze, and he knew what he was doing about, where us, we never dealt with that before. We had no experience in doing that, and so we learned. Sometimes they're there. And I also suggested that we get rid of the linen because of the nasty stuff to work with, and go with Dacron at the time, which was the sale material. And so some of our people were a little bit concerned about that, and so said, well, I'll tell you what, why don't we have him to give us a whole bunch of samples stitched up, pay for him to give us samples, and I built a fixture, put in a test fixture, and pulled all these samples to see what kind of stitching pattern that we thought would be the best for what we needed. And we came up with it, and we had just sewed a tube and put the main beams through that tube in the fabric. And he said, well, you know, in the sailing industry, we have a slotted tube that we attach to our mask, and we stitch a rope into the edge of the sail, and we slide it up there. So we got to the next one of the next go-rounds. And this is the configuration I call AB, that's after Bruce. We're checking out a new pilot called Bruce, and Bruce was on tow, and I was driving, following along in a chase vehicle, and every oscillation he got out higher to higher bank angle, and he kept going. It was obvious that he was diverging, and he did it at 55 miles an hour, did a wiggle over into the lake bed. I asked him later, I said, Bruce, I said, didn't you know that you were getting higher and higher bank angles, and things were getting worse? He said, never dawned on me at all. He said, I thought I had perfect control of the vehicle until the sky turned brown. And Bruce and I used to have a running conversation, ongoing thing, through things because he had some other incidents also. He kept saying, he said, Dick, he said, I don't know whether I'm going to survive your engineering or not. And I said, Bruce, you'll do just fine if you'll quit breaking my toys. And so that was an ongoing thing between myself and Bruce. And just as an aside from all of this, the first time I ever flew an airplane, we borrowed an L-19 from the Army unit on Edwards, and we're using it to tow the paraglider. And Bruce was one day had a task to take some paperwork up to Tehachapi and a tow rope to a glider school up there. It was the place where I learned to fly sailplanes, was up in Tehachapi. And I seen Bruce getting into the L-19, and there was nobody else trailing behind him, so I run over and said, hey, Bruce, where are you going? He says, I got to take this information and stuff back up to Tehachapi. He said, well, you got anybody going with you? He said, no. I said, well, can I go? He said, sure, get in the back. So I hopped in the back, and we took off, flew up to Tehachapi, dropped off the tow rope, and picked up the paperwork. Well, I didn't know it, but our pilot, Milt, who was on pictures of here, was up flying in T-33 that day, and he knew it. And so when we took off out of Tehachapi, we got up to altitude. We had to climb up over the ridge to get over to the desert. And all of a sudden, Bruce says, where is he? Where is he? I said, what do you mean? What do you mean? He says, I see the shadow. Milt's flying. He says, where is he? And next thing I knew, the T-33 pulled up, which looked to me about 8 inches in front of our airplane. And so Bruce dumped the stick forward and got down about 40 feet off the ground. We flew across the valley, up a little valley and over the ridge, and got onto the desert. And we were getting close to the base, and Bruce says, well, we're getting close enough to base. He won't screw with us anymore. So I said, okay. And Bruce says, you want to fly the airplane? I said, oh, sure. And so I grab the stick and get my feet on the rudder pedal. He says, okay, you got it. He leans back, puts his feet up on the dash, lights up a cigarette, and I'm cruising on over the base. And we got over the dry lake and we're approaching the base, and he finally said, okay, I'll take it and we'll go in and land. So we landed. I got the airplane and I said, Bruce, I want to thank you very much for the opportunity to fly. He said, oh, no problem. I said, yeah, but this is the first time I had ever flown an airplane. So that's Bruce's first crash. Then this is what the vehicle looked like after we rebuilt it. The problem, if you noticed in some of the other ones I didn't point out, but the long overhanging stick was literally a big spring. And flying this, unlike flying an airplane where you move the stick and you move a control surface, the control surface gives the aerodynamics a chance to move the airplane. On a paraglider, what you're doing is you're shifting the CG, and once you shift the CG underneath the wing, then it finds itself a new position to fly. And with this big overhanging stick, it was like having a big spring. To this day, I don't know how Milt was able to do it, because consider you had a car that between the steering wheel and your front tires, you had a big spring. And so when you wanted to turn, if your turn was up there, coming up, say, at about the back wall, by now you'd have to start putting input into the wheel and figure out how much to put in to make the turn you want to make. And we decided they wanted to make it a more positive control surface, so I ended up designing, and you can't see them here, I have a picture later on that you'll get a little bit better different, but when the pilot moved the stick through cables, I had to go through a couple of series to get the gearing to where when he moved the stick, the wing would move. And I'll point out something else right here. You see there's no bungee up there on the wing to the tower either, which we had to add later because the forces on the stick were so heavy that he had to fly it before we added the bungee to sort of trim out some of the longitudinal forces. Had to fly with both hands on the stick. And there's, you can see the wheels there. There's a big one and a small one attached. I had to go through two of them to get the gearing to get so when the pilot moved the stick like this, the wing moved through the angles we wanted. This was a day that was rather exciting for me in a couple of aspects. Neil Armstrong was flying the L-19 that day, towing Milt. And they took off, and yours truly was sitting on the ramp at NASA on the edge of the lake bed, and we watched them, and they took off, and they got across the lake bed. We lost track of them. The fellow I had with me and I sort of lost track of them, and we were looking to try and spot them and where they were. All of a sudden, we seen the L-19 circling down, coming down to the lake bed. We couldn't see the paraglider. And so we said, well, something's happened. So I was behind the wheel of a 61 Pontiac station wagon that had a big UHF radio and batteries in the back of it. And so I floored it, and that old 61 Pontiac had a straight 6 in it, flathead 6. And I had it wound up about as tight as I could get it to go, roaring across the lake bed. And I'd never been out on the lake bed, the far side of the lake bed before. I was only on the local area around our facility. And the fellow who was with me says, you know, he says, I think out here it gets rough. And all of a sudden, what appeared before me looked like the Grand Canyon. Water on these lake beds settle, and then the wind blows them around and smooths out the lake beds, and that's what keeps them flat most of the time. And sometimes when they don't get enough rain during the winter, lake beds that they have for emergency sites, they have to go out with road equipment and do some grading. Well, where the water settles and the low spot on the lake bed, there was some pretty deep erosions. The first ridge I went off was probably about a 15-inch drop in a Pontiac, Plymouth rather, doing about 60 miles an hour. And got that all under control, got over to where the L-19 had landed, and Milt was walking down. What happened is we had a 1,000-foot tow line. Milt was going that way. Next thing he knew, his tow pilot Neil were going that way. And on a 1,000-foot tow line, the tow line doesn't go up to that turn point and go around. It starts to sag because all of a sudden now the distance between them is shorter. And Milt got down, and he's afraid he's going to be drugged through the sagebrush. So he decided he was going to release, and he tried to make it to that road. Well, he didn't quite make it to the road. His touchdown was good, his rollout was good, until his left wheel caught a clump of brush, and it broke the strut pin, which was just a 1/4-inch bolt that went through there, and flipped him over on his side. The next vehicle I'll talk about is the M2F1, the lightweight lifting body. The lightweight lifting body was, again, a proof of concept vehicle, but it was thought to be a vehicle that would be used as a reentry vehicle. And again, within NASA, there are two groups of thought. Those that felt that it was going to come into the atmosphere, it had to have wings, and there are those who were a proponent of a lifting body reentry vehicle. The vehicle itself was the nose gear on there. It was a Cessna 150 nose gear, and we initially started out with Cessna 150 main gear assemblies. And when we initially started flying it, we did not have an injection seat in it, which is shown there. And that's Milt Thompson there, our pilot that was the chief pilot for both of these programs. The plywood shell was contracted out to a fellow by the name of Gus Brigleb, who designed and built plywood sailplanes. His facility was over at Lake El Mirage, which was not very far from our facility. And the primary construction of the shell was 3/32 mahogany plywood. The primary structure that the gears were attached to was, again, tubular frame aircraft steel, and we built that stuff in-house. My design part on it was I designed the attachment of the nose gear to that carriage, and also designed the main landing gear on the system. We had a time when Bruce checked out in this, and he flew it and touched down just a little bit hard. Not that his landing was that hard, but our initial things and not thinking, we ended up using as much off-the-shelf simplistic items as we could. I used an automobile shock absorber in there to be the shock absorber, and of course the bungee cord as my spring on the landing gear system. And this day we wanted to get as much altitude as we could get. And we're using our C-47 to tow the sailplane, to tow the M2. And we were down to a climb rate of a matter of a couple of feet a minute was the best we could get. And so Bruce was on tow for a long time. And the temperature profile on the desert in the summertime was that you start off, you're pretty warm, and you climb up, and for the first few thousand feet, the temperature all of a sudden takes a big, huge drop, and it really gets cold, way below standard day, what's called standard day temperature profile. And cold soaked him there. He got up to a little over 13,000 feet, not quite 14, I don't believe. And he was on tow up there for probably about 45 minutes. And so when he touched down, we were thinking that a little extra sink rate that he had when he touched down a little bit hard, that those struts just did not respond at all. And he sheared both main gear and wheel and brake assemblies off of the landing gear. And it was very interesting because at that time we had an over-the-shoulder camera looking out the cockpit. And when everything settled, it came to dusk, you had these two wheels just slightly out of phase, bouncing across the lake bed, going to infinity. So when I redesigned it, what we did is we had somebody go contact Dow Corning to get a fluid that had a very minimal viscosity change over the temperature range we were going to work with. And I designed a cylinder with a flow-through rod so that both sides of the cylinder, when it moved, you had the same volume on each side of the piston. And we orificed it to where we got it to where it worked and we didn't have any more problem with it. I also went to a Cessna 170 main gear axle and brake assembly rather than the 150. The primary difference was that the 150 had a shorter pattern on the axle and used a 4 inch bolts to hold it to the landing gear. The 170 went to a 5/16 inch diameter bolt, and the spread on that axle turned out to give you much more strength on that. We never had any more problems after that. When we come to this vehicle, here comes in the thing. We decided that those international carryalls would not deal with and have enough power to tow the M2F1. So we went out to look for another tow vehicle, and we decided we wanted a convertible. So we went out on an RFP, which was a request for proposal to buy a vehicle. And what we wanted was a car with positive traction, with 4 on the floor, and the biggest engine the company had at the time. Chrysler came back with a proposal of about $8,000 or $9,000 for their convertible. Ford said they wouldn't sell us one because they wouldn't sell us a car that had a standard transmission and a positive traction. GM came back and said, we'll sell you a standard Pontiac Catalina, 63 model. And for about $6,300 at the time is what a Pontiac Catalina convertible cost. And so we bought that. So then the question is, how's our director going to justify buying a Pontiac convertible for NASA? So we had it delivered to our back gate, and when it came in, the first thing that happened, it went directly to the paint shop, where the first thing they did was took the trunk and the hood off the car, painted it yellow, put it back on, and it came with bucket seats up front. Took the right-hand bucket seat out, turned it 180 degrees and mounted it back to the car, removed the bench seat in the back, and put a bucket seat in the back, which was behind the driver's seat, facing out the passenger side. And we decided they wanted to roll bar in it for safety, so we took the car and took it down to Mickey Thompson's speed shop in LA and had them install a roll bar and blueprint the engine. And then they came back and put NASA on the side. They had a highway patrolman stop them on the way back. He'd never seen a car with the passenger seat facing aft and somebody in it and a roll bar in it in a convertible like that. So he had to look at it. So he stopped him. To calibrate the speedometer at that time, we could have done it on the base or on the lake bed, but we figured the logistics of doing that with the base operating in its normal routine would be more trouble than it was worth. Besides, Nevada not being that far away, at that time had no maximum speed limits on the road. So a couple of our guys took the car and a stopwatch and the measuring device, and they went to Nevada and they set up a speed course down one of the back roads out in Nevada, and they calibrated the speedometer up to about 110 miles an hour. And they were making one run, one of the high-speed runs, when a Nevada patrolman came down the other road. And they thought for sure he was going to turn around and come stop them. He never gave them that. He just kept going on down the road. So that's the story of the Pontiac convertible. This next picture is actually the M2, and that's the C-47 out in front towing it. Even with 1,000-foot tow line, you can see how much sag there was in that tow line. It was historically known as the upside-down bathtub. This was just one configuration. When they got to the heavy rate versions, they had several other configuration lifting bodies. If you go onto YouTube and look up lifting bodies, you'll find a lot of stuff, a lot of clips, and they talk about a lot of the other configurations. Langley had a version. The M2F series was NASA Ames version. The HL10 was the NASA Langley version. Then the Air Force came up with a couple of versions also that they ended up flying. This is the ejection seat. We went out on an RFP again for an ejection seat. We wanted a 0-0 capability ejection seat with an installation weight of less than 100 pounds. And when we got responses back, Lockheed came back and said it's impossible to build a 0-0 ejection seat for under 100 pounds and recommended we use their F-104 ejection seat. We had an installation weight of like 400 some odd pounds, and that was way beyond our allowable limit. And what made this, Weber Aircraft is the one that designed this seat. They took the ejection seat that was in the Tweety Bird, the T-37, which was just a catapult seat. If you don't know the difference between a catapult ejection seat and a rocket ejection seat, the catapult seat just has a charge in it. It basically kicks you out of the aircraft, and you need the velocity to go to make the rest of the system work. 0-0 ejection seat in a rocket catapult seat, once that fires, the catapult gets you clear of the airplane, a rocket motor lights and gives you extra altitude. Even with that, they ended up having to put a drogue in the parachute that had a slug in it, that when seat man separation occurred, it fired that drogue, and that had about 1.5 pounds weight on it, and it fired it up off the left-hand shoulder of the pilot, and that opened the chute bag and extracted the chute out, and that cord had a length that was just a little bit shorter than what the canopy stretched all the way out would have, and that was a line that would break then, and the slug would continue on somewhere else. And then as soon as the pilot started to lose a little altitude, the chute would inflate. So it got it there. The next slide is our static test firing. You can see the windshield, and we fired through the canopy. We did not get elaborate enough on this vehicle to build a mechanism to get rid of the canopy. We decided we would just, the pilot would have to go through the canopy, and that's what we did. And that's it, and that's right after the rocket motor fires. In developing this system, we had some problems. The first 3 tests we had were failures. They had problems with seat man separation. And what happened when the seat fired, when seat man separation happened, there wasn't enough energy between the two to pull the cable and fire the chute. And so what happened is the pilot basically, or the dummy in this case, stayed attached to the seat as he went through the air. And they had a recovery chute on the seat, so when the recovery chute for the seat deployed, that gave them enough force, that had pulled it, but by this time the dummy was too low and the drogue never fired, until he hit the ground. And it's rather very alarming to see this thing and keep telling your guy, that's a dummy going through there, it's not a guy flailing up there. We never had to bail out of this one. However, this seat was later used in what was called the Lunar Lander Training Vehicle, which was the simulator for a moon landing. And Neil Armstrong, and the seat was modified from it. Initially, this seat, the pilot had to put the parachute on, and he wore it on his back and he got in there. They later decided that carrying that drill gun around in this parachute was a hazard, and so they modified the seat to incorporate the seat into the parachute, and then the pilot just wore a harness. So when he sat down in the seat, he snapped in and was there. Neil had to use that seat to eject out of the LLRV, which was the Lunar Lander TV, actually, the Lunar Lander Training Vehicle, when they didn't get his control rockets fueled properly, and he ran out of fuel on his thrusters and couldn't control it. He had to punch out. And he walked away from that. So the basic seat did work, and there was that. And I think there was one other incident. I think they lost another one also during the astronaut training. Somebody else had to punch out of the system. And there's the lightweight lifting body and the heavyweight lifting body. And you might remember the heavyweight version of the vehicle if you're old enough like I am, and I think the majority of you here probably are old enough to remember the $6 Million Man movie series. The crash that was the lead into that was, again, my friend Bruce. He was flying this vehicle when that crash happened. What happened is, if you've seen it, was a very tumble, and you look up the M2F2 on the internet, and you can find several series of it, give you a better series of what that crash looked like. But consider this was flying and touching down at basically the speed of a 104. You're going about 150 knots at touchdown. And Bruce got distracted by the rescue helicopter, and he pushed the nose over to try and avoid it. And when it does, the M2 version at low angles of attack became very unstable. The lateral directional stability just went out the window. And he was, again, rolling way past 90 degrees, plus almost up to 120 degrees on each side. And when he finally decided he's getting low, and he was so concerned, he did not hear any of the chase pilots tell him to put his gear down. And he decided, he started to flare, and when he flared the vehicle, he leveled out just a matter of inches off the dry lake bed. And he decided he needed to put the gear down. When he put the gear down, he's so close to the lake bed, and on those vehicles, because they didn't need hydraulics, rather than using hydraulics and have a slow gear extension and retraction time, the gears were all retracted before they were attached to the bomber to be taken up to launch. They had a pneumatic system, and so when the gears come down, when you went to your gear down on the handle, it was almost a matter of just a fraction of a second, and the gear was down and locked. And so his gears came out, and they caught the lake bed and caused the vehicle to start to tumble. And it went end for end and then rolled. And when that happened, it broke his helmet off, and it literally ground his right eyelid off. And it worked lake bed dirt down around his eyeball, down the optic nerve almost all the way to the brain, his brain. And the doctors initially said, he'll never see out of that eye again. And when he started to recover, his body started working the dirt out from behind his eyeball and whatnot, and he could start to see shades of light and dark. Oh, wow. And they said, he might be able to get his sight back in that eye. He'll need an eyelid. So they started a procedure of rebuilding an eyelid for him. And in the process, he got staph infection in his eye that took the sight out of that eye from there. One of the upsides, if there is any upside to that, is that they initiated a program for him as a pilot to fly. And they found that if he went into airports that he was familiar with, he could actually fly in 104 and land it successfully. But if he's at a strange airport without his binocular vision, he was totally lost. He couldn't gauge sizes and distances enough to successfully land a 104. So what do you do with a pilot that's that? You make him your safety officer. And that's what Bruce's job was after the M2 accident, and he couldn't fly any longer. That, in conclusion, what I'd like to say basically is that the proof of concept of a vehicle, and a lot of companies used vehicles to build proof of concept flying vehicles. Excuse me. And in this case, a demonstration that these really extreme configurations could be controlled by man was an initial start. Even though the paraglider, we did actually build a paraglider that had inflatable booms, because for the Gemini capsule, what had to be carried had to be stowed in a compartment where the parachute initially was. And they attempted to develop the system, and the first one, they built a boilerplate capsule, and they threw it out the back end of a C-130 and inflated the booms, which it did, and it got into a spiral, continual spiral. And the next thing they did is they got a guy to fly it, and they did the same thing, and the vehicle got into that capsule, did the same thing, got into that spiral, and even trying him maneuvering the wing, he couldn't stop it, so he had to jump out. And by this time, the Gemini capsule was ready for starting flights and whatnot, and they felt that the time required to develop that system would not be adequate to make it viable for the Gemini aircraft. And in the case of the lifting body as a reentry vehicle, like I said, there's two groups of NASA, one that wanted wings and one that wasn't, and I guess it brings up the old thing, you gotta remember the golden rule. And that is, he who has the gold rules. And those that had control of the purse strings were in the group that decided a reentry vehicle had to have wings. So we ended up with a shuttle rather than a lifting body as a reentry space vehicle. I was lucky enough to start out working at NASA and getting on these programs and working on some of the slowest flying vehicles that NASA ever flew, and also got a chance to work on some of the higher flying vehicles. I'm talking about air vehicles that had air-breathing propulsion systems in them, all of the XB-70 and the YF-12 Blackbird. And those are stories for another day.